Hello, everyone, and welcome to today's webinar, Optimizing Wind Turbine Performance. My name is Jeremy Arndt, and I direct the renewable business here in North America for Bureau Veritas. And I've been with the organization for about 4 years, leading efforts within the North American region. A little bit about Bureau Veritas before we get started into the topic today. We're a large multinational company organized in over 140 different countries throughout the world. Do a turnover revenue of about $5 billion per year and over 80,000 employees. We work with a variety of clients in many different industries, including the power industry, which we're going to talk about today. And one of the topics as well today is on our laboratory network and how we support different initiatives within the OPEX region. Regarding our power and utility group and renewables group, we have vast experience in the onshore, offshore, and solar space and continue to grow and strengthen that. We've been within the onshore business for over 15 years, supporting a variety of scopes and services across the globe, as well as we get more involved into offshore wind as that continues to expand. And one of the really strong areas of growth in the past within the industry has been solar, and our team continues to see strength in that space as well, supporting anywhere from the IPPs, renewable developers, financial firms, and utilities. As you'll see, we have quite a network of expertise throughout Bureau Veritas within our global reach. The offices that are supporting the scope we talk of today is located in Houston, but we have a variety of areas that we support and service lines throughout the world, which gives us strength to support projects throughout their life cycle and development across the world. Regarding the services that Bureau Veritas can assist, we work anywhere from the CapEx side all the way to the OpEx side, which we'll talk about today more, but in specific nature with development support, things of owner engineering, reviewing design on projects, all the way down through construction management, overseeing the construction and capital build out of these large projects. We also have a certification group that supports product certification and project certification, along with asset operation and asset management, which today is the main topic that we're going to talk about, supporting optimization of assets that are already in existence. So as we jump into the content today, on the agenda, we're going to look through 5 different sections. The first section is going to be looking at specific gearbox oil for the wind turbines that are out deployed in the global reach currently. We're going to secondarily look at the modes of degradation and then the analytical tools that will help us understand the modes of those degradation, and then really drive into some case studies that are specific to these topics, and then come upon with some conclusions and have some time for Q&A. So at this point, I'd like to introduce our global expert for our OCM group, which is for oil and analysis, which we look after over 20,000 different wind turbines throughout the world. And I want to introduce and kick off the topic of technical nature with Jorge Alarcon, and he'll be leading the discussion from here.
Thank you very much, Jeremy. So I've been involved in with the oil analysis and lubrication in wind turbines since 2008. I saw a lot of different, I saw the transition that the industry had from especially the size of the turbines and the gearboxes, and also the different type of oils and lubricants that this type of industry has been using through the years. Of course, that there's a large difference between what we when we started doing oil analysis back in the early 2000s compared to the ones that we are doing right now. Right now, we have tons of data, a lot of information. We gain a lot of knowledge through that time. So, which is what we are trying not only to increase, but we'll at the same time, what we are doing is trying to offer that expertise to our customers. So when we talk about gearbox oil, we're talking about very developed technology that we are using in the gearboxes right now. it contains many different type of properties that they are trying to basically extend the life and service of the gearbox. If we go back to the initial years of the wind industry, the gearbox oil used to be changed every year, and for some reason we start seeing that that thing change a lot with the years. So now we have seen sites that are using the same oil for about almost 18 years in some cases. So we are talking about a technology that has developed through the years at the same time as the power increasing on the turbines. So if we go back to the initial year 98, for example, when we start doing the first gearbox oil analysis and grease analysis, we've seen that initially around 89% of the oils were mineral oils. If we compare that that data with the one that we have here, we can say that depending on the country, 74% of the gearboxes are now synthetic, especially POA type of oils mixed with an ester type of oil. So the in-service life of the gearbox has changed dramatically. Of course, at the same time, we have a difference with price, but basically what we are seeing right now is gearboxes that are using the same type of oil with a little bit added through the years, a very low volume added through the years, but we are seeing turbines that are having the same oil for almost 20 years. And that's especially what the market is demanding, right? So what the market wants is one type of oil that can last longer and try to get as the same time as the gearbox. And we are not moving into many different type of fluids, like ionic fluids, for example. That's something that at some point we are going to see. So we're going to see that transition in the next 10 years, maybe. Right. So why is it important to control the health of the oil? So it's very important, especially not only for the oil, but especially for the components of the gearbox, right? The teeth, the bearings inside of it. So if we go back to the initial years of this industry, we said that a mineral oil was there for less than 3 years. Now we have synthetics running for more than 10. So the oil failure mode changed dramatically through the years. So we are not seeing the same type of failure modes that we've seen at the beginning of this industry when we started using mineral oils, but also when the synthetics were added into the gearboxes, the failure modes were completely different than the ones that we have now. Same thing with additive depletion. For some reason, some additive depleted different when we talk about the same technologies, the same type of oil, and exactly the same happened with some other characteristics of the oil, compatibility, for example. Now these days, the entire world is shaken because of there's no enough probably lubricants in different countries. In some South American countries, for example, it can take about 6 months to get the correct proper lubricant for the wind side. So we are seeing a lot of compatibility problems these days, things that we never saw before in the past year. So basically, we're trying to go with not only with the market, but with the world situation. So in this run, we are trying to fulfill the entire demand of what the customer needs, basically. So trying to keep the oil in a certain state will need a lab and enough knowledge to understand what's really happening with that oil. So when we talk about oil analysis, we are talking about just a small sample, 4 ounces, no more than that. When we talk about grease analysis, we're talking about less than 20 grams of grease. And after running the entire test package, the customer expectation probably is not what the lab can provide. Initially, what the lab is providing, or what the lab is telling, is the oil health, the component health, or how the grease is behaving in certain situations. And so, in the other hand, what we have is the customer. So the customer wants to know the oil expected life in one gearbox, for example, or the component reliability, right? So there's a gap between what the lab can provide and what the customer is expecting. So what we try to do through the years is closing this gap. So what we are really doing right now is trying to answer that customer question. So how long is this oil going to stand for? About a year, 6 months. So that is the main question probably when we talk about oil analysis in this field. So when we talk about the same technology, for example, now all of the a large majority of the turbines are under a same umbrella, right? So we are talking about one OEM, different countries, same technology, and same lubricant in many different situations. So it is important to know that the failure mode of one lubricant that it's in North America, for example, it's completely different than the failure mode that the same lubricant and the same technology will have in Europe, right? So we're in South America or Australia, different countries. So what we learn through these in this time is that we need to not only to maintain one specific test package for this industry, but what we need to do is trying to look for that specific failure mode, and that will require that we need to start developing different types of tests, right? So we need to look for different analysis, trying to understand what's happening with that specific oil. And even though that is the same technology, same lubricant, and we probably we have a failure mode in Europe, which will not be the same failure mode that we have here in North America. So it's very important to understand what's happening with that specific oil in a specific location. For example, when we talk about viscosity, these oils, 320 oil, very typical for the wind industry. It's located in one specific location, and what we can see is that the failure mode from the viscosity point of view is that the decreasing of viscosity. So basically, the hydrocarbon change is it's breaking through the years, and it's creating a very low viscosity content in this case. So, for example, this specific situation doesn't apply for the same type of lubricant in a different zone. So, depending on the operations, depending on the environment, and depending on many other factors, what we are seeing is something like this: that viscosity, which is probably the most important physicochemical property in any oil, is not behaving in the same way in all the sites. And exactly the same when we talk about degradation, right? So when we talk about how the gearbox oil is degraded, we have many different types of degradation. Like in this case, just a small amount of layers in this graph that we are seeing that they are suffering of different type of degradation. But in the majority of these example, what we can see is that there's no degradation of the oil presence in this entire farm. This is a site, right? So if we compare these type of degradation with a different site in a different location, we will see a completely different picture. So what we are trying to do, it's trying to understand how the oil degrades, and the oil degrades in a very different ways depending on the location. And there's the same thing happens with additive depletion, right? Through the years, we have seen how the lubricant industry has been improving their lubricants that are used in the wind field. So same thing with additives, right? We know that additives are very important. They are providing the lubrication film in when we talk about loads in a lot of extreme situations. So we need to understand also what's happening with the additives, how they are depleting. Why is the reason that they are depleting? Is there something that we can do when we found an accelerated depleted of the additives? So those are the questions that we are trying to answer to our customers, and we are trying to close that gap that we had initially, mainly because there was a lack of knowledge. But after 20 years of running thousands of analysis, we are really close to understand what's really happening, I would say, with every single type of oil, but with the majority of the oils that are used in this field. So what we are saying is that different failure modes require different type of analytical approach. In this graph, we can see the fingerprint of two different oils in this industry. So these two different oils are going to behave and are going to degrade in a different way. So trying to understand requires a different type of analytical approach. So basically, we cannot be using the same test package for these two type of oils, because either way we're gonna lose the track of one, or we're going to lose how one of these are going to degrade, and that will have an impact on the gearbox, right? And that will have an impact on the availability and the reliability of the turbine, which is something that is very important for us. So we are trying to focus into an early identification of the problems, early identification of the failure modes based on the different type of oils that are in the field right now. So what about fleet limits? A lot of companies work with limits, especially for oil analysis, but unfortunately, oil analysis is not about a fixed limit. So let's take a look at this case study here. So for the last 4 years, around 4 years, this site has been changing the gearbox oil after each sample due to the increasing viscosity. At the same time, they noticed that the filters lost efficiency at around 40 to 50%, depending on the turbine, of their useful life, and the filters had to be replaced. Also, the oil temperature was increased, again, depending on the turbine, between 5 to 12 Celsius in the last 2 years. And at the same time, the valve that controls the oil flow to the gearbox had to be replaced in probably 20 of these turbines due to the amount of slashed addering to this valve. And we can see how this sludge is it's in the filter, so the filters need to be replaced because the oil is not flowing properly. So if we go to the fleet limits in this case, we can see that initially we are working with a simple PAO ISO 320 oil, while the site has been using a different oil. It's also a 320, but it contains a different chemistry. In this case, it has a pickup ester in the chemistry. So if we go to the limits, we will see that the previous sample was under the limits, everything was perfect, But if we take a look, for example, at the particle count, the particle count was very close to the limits. However, the site was having a lot of problems, and we can see how the viscosity was increasing to 345 around the to 350, very like 5 centistocks above the limit. So in each situation, the site manager has to decide what to do with the oil. Change the oil because the viscosity was over the limit. Change the oil because the acid number in this case was not over the limit, but it was under the limit. So what really happened with the limits? It was not fixed for the proper oil. Same thing with the additives. The site manager decided to change the oil because the additives were under the limit, right? And so what is the situation here? What is happening? That's the most important thing. So a lot of people change the oil. A lot of sites are using different types of oils, and the fleet has never updated their information in the limit system. So what happened when we have this type of situation, when we are mixing oils? Initially, the additives are the first ones that suffer in rapidly depletion. So depending on the type of additive, the additive will start consuming because it's happening a chemical reaction inside the gearbox, and the additives are the ones that suffer this reaction first. Have an incompatibility between the oils that will create this chemical reaction, and maybe it will affect the viscosity. In some cases, the new oil has a different viscosity than the previous oil, so it will be just a compensation on the viscosity. But we don't have to forget that a chemical reaction in some cases can break the hydrocarbon change, and that will create a different viscosity, at least a portion of it. And after the site has found this problem and tried to correct the situation, the contamination with the previous oil, after the gearbox was clean and flushed, not only drained the oil but flushing, we found out that the previous sample was there in the gearbox for around 3 to 4 years, in a concentration that initially was around 10%, and at the 4th year it was reduced to probably less than 2%. So the previous oil, even if the site decided to do a flushing, remained there. And of course, a remain of the previous oil means that the chemical reaction, if it's a wrong reaction, probably will continue through the years. So in this case, not only cleaning the gearbox, but also in these 4 years, it was necessary to replace or sweetening around 40 to 50% of the amount of oil in the gearbox. And same thing when we talk about grease, right? So especially these days, because of the problems that we are having on the logistics side of the chain, for example, a lot of people start mixing greases. So we can see here, probably is not a big issue mixing two greases that contain the same type of thickener. But if we take a look at more in-depth analysis, we can see that one of these greases has viscosity oil of 15 centistocks, and the other has a viscosity oil of 400 centistocks. In this case, for example, the main bearing was lost in about a month, just because probably no more than 5 kilograms of grease were added to the main bearing. So grease analysis is also one of the tools that we have been working through the years, and it's providing a lot of good results to our customers. They are seeing how to not only improve the grease performance, but also they are seeing how the bearings are at getting more into when we talk about grease analysis. Same thing. So when we talk about failure mode, and we are not talking about grease analysis or grease failure mode in this case, but we are talking about main bearing failures. So we can see that two different sites that they are using the same type of technology, the same type of grease, are having a completely different failure mode, completely different type of failure mode. So it's very important to try to understand what's happening with the grease when we do a grease analysis, because that grease analysis will lead us to know the main bearing or any other bearing in the, could be the blade bearing, for example. We will know how these bearings are failing. And if we know that, we can probably take advantage of this situation, and we can, for example, schedule a main bearing replacement very early, or we can do some up tower tasks to solve the situation instead of waiting until the bearing fails completely. Different part of this game has been rolled by data analytics. So all the knowledge that we have been developed through the years, and all the information that we have, tons of information. It is good. It's very important to have, but it is very important to use that information too. So data analytics has been plays a very important role when we talk about not only failure modes, but when we talk about trying to understand not only the oil analysis part of the situation, but also the behavior of the components in the wind turbines. Right, and couple of notes here for if you are a fleet manager. My recommendation is to try to know the lubricants in each site that you use. Not all lubricants fail in the same way. Knowing the failure mode of each lubricant will improve the turbine availability. And the last one is very important. Do you know, or do you have an oil lubricant analysis specialist or expert in your team? Probably that's one of the most important things when we talk about the oil analysis in this field. And for the site managers, so are you using an appropriate sampling procedure? Sampling procedure is probably one of the most important parts of the oil analysis. So proper procedures for transferring oil to the gearbox is also very important. I've seen a lot of problems, people transferring not only dirty oil, but already degraded oil into the gearbox. Apply the correct grease to each bearing. As I said before, these days we are seeing a lot of problems with cross-contamination, especially between greases. And people think that grease is grease, just the grease. But as we've seen before, there's more behind that than the thickener. And effective communication with either with the lab or with your oil analysis specialist will help you through this area.
Excellent, thank you, Jorge. So that concludes the technical piece of our presentation today. You can certainly reach out to myself or Jorge at any time. We've provided contact information here, and it's interesting to hear the different failure modes and different things going around the world. So wherever you might be, even if it's not North America, and have questions, we'd certainly have some input on that and be able to share some of our technical acumen. Right now, we want to open up to a session of Q&A where we can ask some questions here live and field any of your questions that come to mind as we've covered the content. So we'll start with the Q&A here and answer your questions as best as we can. But again, feel free to reach out.